Hi everyone, welcome to my channel. I'm José Cruz, I'm an enterprise architect, and today I'll be talking about ETags in APIs. Let's see what it is. What is an ETag? A tag is a version fingerprint of a resource representation. Okay, it's a quite nice definition, but at the end of the day, imagine that you have some data in a table or files or similar, and you want to make sure that you only download or get this data if you don't have it already. Imagine that you download the file from a server, and this file can change on the server. Imagine that it's a configuration file, which by the way was a project I developed a few months ago. So, and I don't want all my 1,000 clients to download every day the files to check if they are new or not, if there are new configurations or not. And usually what I create is a kind of a version fingerprint, a way to identify my file with just a few characters. It can be a version, it can be an hash. I will show you 4 different ways to do it in a moment. And now the client, if it sends me a specific HTTP header, I can reply to it and say, okay, you are asking me about, you are providing me that fingerprint, and I can say to you it's the same that I have. So it's not necessary for me to provide you the file. You can use the file that you already have. But you can see the other way around. Maybe you are editing a kind of details of a user, and you want to make sure that when you update this data, that in parallel another update didn't happen, meaning that you'll be updating a kind of outdated information. You receive, let's say, an address that you are correcting, but someone on the side or some service already corrected, and maybe it's different, and you don't want to force the update. You want to be advised by the system, say, hey, you are providing me that, but it's already updated by someone else. What do you want to do? I can give you the new version and you do whatever you want with that data. And you can accomplish that with this ETag, and you'll see in a moment how. So let's see an example. Imagine that you, for some reason, you already, in this case, it's not an update, it's a get. So you get the specific, let's say, imagine that it's a blob or an article, and you have this ID 42, intro to ETag, a tiny header with big impact, something like that. Now, when you, in your API, if you think this data can be updated later, or if you think that this data it's requested a lot and most of the time it doesn't change, maybe you should reply always with an ETag. It means that your API will be responsible to generate this ID, and you'll see in a moment how. And it, at the end of the day, it's your creativity. There is no specific standard for this. It's just something that should represent you in a unique way, this content. So you generate this and you provide this to the client that requests this resource. Now later, the client will send you this information in a specific way, and then you can check if the version that you have locally still generates the same ID. And if still generates, you don't, the next time the client wants or requests, let's say, a get, you don't provide the content, you just provide a specific code, a 304, saying, okay, the content, it's the same. Let's see how this can happen in a moment. So why do ETags exist? This is just a few examples. There are others. One is cache validation. Imagine you are a client and you have some data on your service, and sometimes you want to know if, and you are cache this information locally, and you have a lot of information or big files or something like that, and you don't want to permanently go and say, I will create a cron job and go every hour getting these files, or every day at midnight, so there will be low traffic so I can get them. A better way is for the server that provides you the files to generate ETags and provide to you the ETags. And now on the cache, rather than download or ask for all the information, you can just ask to the server, say, okay, in my cache, I have these ETags. How many of them change? Okay, you have 10, only 2. So give me these 2 files, because they are the only ones different. So you can spare a lot of traffic loading on the server and things like that, because you only get what you really need. The communication to reply 304 is just a few bytes rather than download, let's say, hundreds of kilobytes or megabytes or whatever it is. Okay, so and this is for the get. Now imagine for the put. So you want to prevent to overwrite, as I said previously, data that it's already overwriting by other service. And then you can again use the text to avoid that, at least to be warned and say, okay, you are trying to update data that was already updated. And usually you'll send an if match, and I'll show you in a moment how, and you will receive a 412 saying precondition fail. Your precondition, it's your ETag. So you are saying, I'm updating this and this is my tag. And the other side said, I don't have any resource with that ETag because it was already updated. And if it's updated, when you generate the ETag, it will have a different number. Another one is if you have problems in the network. Sometimes you upload something or you put something and it was accepted, but there was the network just broke. Now, rather than try to upload again, you can first ask and do a get and say, okay, or you can just put and say, okay, this is my ETag. And the other side will say to you, okay, it's good enough. Or maybe you can do a get and make sure that ETag, it's the same as expected. And then it's safer that way rather than try to do one put, two put, three put. Okay, but it's the put usually in APIs, they are idempotent, meaning that if I execute several times, it should maintain the system on the same state. That's true, but it's not the best approach if you are talking about thousands of clients accessing your server. That's true when you are creating an application where you have a back office and you just update this data and you just call the API. From the first point of view, it seems that as is. But if you think about, okay, I'm creating an application, imagine it's an Android application that can be used by thousands of users, and this can happen all the time. Maybe you have to create some mechanisms that will allow you to spare as much as possible the traffic and the loading and CPU and memory on your server, because at the end of the day, you have to pay for it locally or in the cloud. So when should we use it? This is just, if you look into it, it's just the how to apply to these three scenarios, but there are others. So for the get, you should use this header. I'll show you in a moment why. For the put or patch or delete, you can also use, okay, only put or patch or delete if the tag is the same, okay, or and again, if it's you have networks which are unstable. So let's see in practice how this works. So let's say usually when you do a get, the server should return to you an header, call it ETag with this. Of course, the server will return because you have to generate and set this header. So the client, imagine that it's a cache validation, will send later a get and say, okay, if non-match and you provide the tag, meaning if you don't have that tag, give it to me the result. And the server can reply to you with the content, or can reply with, and probably the result will be a 200, or it will reply to with a 304, say, okay, what you have, it is the same as I have, so nothing was changed, so keep it what you have. There is no reason for me to provide you the data that you are requesting from me because you already have it. Okay, now if it's the other way around, if it's a put, you want to think on the other way, and you say update this information, but only if the tag matches here. And if it doesn't, which means that the data was already updated by another entity, the server should return to you 412, say, okay, I will not accept your update because it was updated by someone else. That's one way. Okay, at the end of the day, it's you that are developing the server. Maybe you can just accepting anyway, and maybe you can put in an audit table or in a log, like a warning or audit log, and you say, okay, I tried to update this. There was some data before that someone update. I update with this information, but the values before these ones were these ones. So you put in a file. So someone later can see, okay, I remember that I update that. I don't understand why it's not there, but this is the reason, because there was another update right after this one that occurred in, let's say, seconds, and there was no time to change the tags. So how to generate tags? Let's see 4 ways to do it. One, it's the straightforward approach and most intuitive one. It's using it just create an hash of all the content that you have. It can be a JSON, it can be a row. Maybe in a row you get in a class and you serialize it to JSON or any other format, and you calculate the hash, and you extract the X format, and then you provide it will be something like this, which means when you reply, you should see on the header of the response something similar to this. So at the end of the day, you acquire the body. Imagine that is JSON, but it can be whatever you want. And then you calculate the tag and you just reply like this. What is the problem with this approach? It's CPU. Imagine that you have thousands and thousands of gets constantly. You are always executing the hash. It's not heavy, but multiplied by thousands, it's heavy. That's and I usually consider this because I have worked in banks, worldwide banks, where it was common to have millions of gets in a day. So when you see things like this, every millisecond counts, because a millisecond, it's a millisecond, but 1,000 things by 1 millisecond, it's 1 second. And you start to see that this can fast degrade your system if you have thousands and thousands of requests. Of course, you can have multiple servers, but then you have other problems too, like session state and things like that to manage. Another version is using versions. It's not that it's approach to generate tags, but some databases, when the data is critical and several updates can happen on the same rows or the same files, maybe you want to version them and say, okay, I will, if I receive 2 or 3 updates for the same data in a specific range of time, I want to create versions of them. Later, I will merge them. I have a process that at night or other times I will merge them and choose one of them. Or maybe because of auditing purpose, this version always increase. In this way, it's quite easy because you just return the version like 3, and if someone does an update, it will be a version 4. Unless someone removes this version, it should be okay, but the ETag at least can confirm if this version still exists or not in the table. But remember that this algorithm, the get, can be a response to any data source. It can be a database, it can be a connection to another system, it can be a file storage, it can be JSON files. I usually give examples of a database because it's simple to explain, but remember that the ETag is related to a resource. And as I said previously, during the last months, I developed a configuration service, and it were files, JSON files. There was no database involved, but I had version there. There was version and there was an hash that I combined to make sure that it works, because sometimes when you have multiple clients, you cannot update all of them at the same time, and you have to keep 1, 2, or 3 versions for a while on your server before you start to remove them. So always consider that. Okay. Another approach is using timestamp and the length. Timestamp, you can go to the seconds. It will be something like that. It means that when we get some information, you do the timestamp. It's quite nice because it's fast. It's just the clock of your system, and then you can put the size of the data that you are returning. Okay, the probability of this be unique, it's quite high. Collision is quite low. But for second, if you have a system that can read the same row from several different places, yeah, it can happen, some collisions. So maybe if you go to the milliseconds, or maybe the number of milliseconds since the 1972 or 97, if you use the Linux approach, okay, that the probability will be very low. So you say, should I use it? Now, the question is not if you should use it. It's, do you want to use the version 1? Do you want to use the version 2? Do you want to use the version 3 of this approach, or maybe a version 4, which is composite weak, that I will explain in a moment. It depends on your scenario. And usually my channel, I try to address things from an architecture point of view. And being an architect or a senior, probably some of you already know, it's about taking these decisions. It's not about, okay, I know a method to generate ETags. No, you don't. You know several of them, and you want to choose the best one for your scenario. Maybe in a system, you can have different approach to ETags in different APIs on the same system. It depends on the data and how it is collected, retrieved, requested, and so on and so on. I hope you understand this specific thing. And if you are an architect, you already know. If it is your ambitions to be an architect, always remember that architect is about trade-off. It's always asking why and why should I choose this option comparing to another. Always try to find an alternative to compare. You don't take decisions because that's the way to go. That's not an architecture decision. It's that, okay, I want to scale, I will just create a kind of mechanism with a reverse proxy and automatically create another instance. It seems easy. Yeah, but if you read the documentation when using a system, now you have two different machines with different sessions. Some data go to one side, the other one goes to the other side. Things that are in memory are not shared anymore. Maybe you have to move to the database. Now in database, it's slower because you have to do a network connection. I think you understand where I'm going. You are always doing a trade-off. Every time you try to do a decision, always try to compare with another one. And ETags, I provide you at least 4. That probably you can find other ways to generate ETags. These 4 are the most common, but you can find your own and it will be okay if addresses the issues or the problems that can arise on your solution. So I'll return to our 4th one. So if you remember the 3rd one, timestamp and length, you already understood the problem, but usually you will see a kind of the timestamp here, then the length. Okay, if it is supposed if you change something, probably it will be adding or removing a character. But again, depends on the data. Maybe I just capitalized this high, so the size didn't change. You understand the issue here, and that's what you should think about the probabilities in this case. Now, composite week. Composite week, usually you know that it's a composite week, and you should write this letter saying that it's week / it's not mandatory, it's a standard, it's just a way for you to understand that it's week. What is week? Imagine that you have this JSON and you are exchanging information with different services, and some of them return to you the JSON in one line, but others return to you with spaces, very nice things, or maybe some attributes that you don't want to consider on your updating. For instance, I will give you an example where I have a specific column which is version that it doesn't belong to the data, it's just to control the data. So when you get the JSON, sometimes you have title intro and maybe another times title intro version. But you want to generate a kind of an hash that says, hey, they are the same. It's the content, it's not the same, but from the semantic point of view, when I return the data for update, they are the same. So there is a kind of a weak composition, because it's not like you are hashing the old data. It's weaker than that, because you are not considering everything that it's there. Carriage returns, spaces, specific columns, you are removing that somehow, or you're just ignoring that, but you want to generate the same hash. And in this case, what usually is done is that we create a kind of a version, the method that I explained previously, and a short hash. That's why it's weaker, but it's good enough. So if you are using versions and a short hash, so it will not be very complex to generate, it will be, it's called balanced, it's cheap from the CPU point of view, and still unique enough. Remember that the idea is to be weak, but may ignore trivial format difference. Okay, it can happen, but the probability by study, by practice, is quite low to have collisions. So you write something like, you put this prefix here saying that it's weak, you put a version and short hash. The version, it's not mandatory, just to reduce as possible the collisions. Maybe you don't want to use the version and you just use a simple hash like the one here with the body and just return it, and it should be good enough for you. If you think it's not good enough, probably you'll need more CPU, you want to clean the hash, and you have to find a way to normalize it or standardize it, or create a kind of a canonical way for the JSON, for the data that you want to update, and go to one of the previous methods. This is just another method, and you return an ETag like this. But usually, if you think that you can receive the same information in different formats, the string will be different when you serialize, but semantically it's the same. Usually this approach, it's quite common to be used. So these are the 4 ways that you can use to generate ETags when there is a get. So let's say someone does a get to get some information like a customer's address, and the client will say to you if it adds this header, like saying something, if non-match, and this is a tag that was generated, you already know what it means. It means that you have to generate on the server side an ETag and compare with this one. And if it's K, it's the same. great, you don't have to download nothing. You should return just a 304. Otherwise, you should return the body of what is being requested. Okay, now you have the put, just to see clear how it works. Imagine that you already get you did a get before for the data, for the resource, and now you update it. There was a nice editor and you say, okay, the new address, it's this one. So update it, you do the put, but only if the ETag it's the same. Otherwise, just tell me, because I don't want to update over information that meanwhile was updated. And in that case, the service should return 412 because, as I said here, someone changed it. Okay. So I will show you this running. This is a minimal server using Python, which is quite simple to implement. The code, it's on the GitHub in one of the, you can see on the posts of the channel, the address of my GitHub, and there is a specific folder called ETag where you can see the old source code. I'll just explain here in 3 scenarios. The code, it's quite simple if you want to understand how the server works, and then I will do a very quick demo with 4 requests where you see this get and put on the APIs working. So I'm using Flask here. From Flask, this is the imports that you can do. This deep copy just to help to serialize something and generate an ETag. So a minimal server, you do a create app. This is the structure of the Python. If you already know Python, you probably already know Flask. It's quite popular. So this is our database. I'm not using a real database. It's a JSON one with this title content. But I like this approach because this version doesn't belong to the semantic data. It's just a way for me to versioning this. If I have another way, I could have another one here, but with a different demo here. Okay, but with version 2, version 3, the version 4, version 5, and so on. It depends, of course, on the scenario. If you don't do the version approach, you can study any one of the 4 methods talked before. So this is just a method to do a canonical JSON to make sure that every time I get the JSON, it's all the same. So I can generate with confidence the tag, which will be the same for the same JSON, meaning this, if I'm returning this, I want at least this code here to always be the same unless something change inside. So that's what this JSON dumps does. This is just to create a ETag tag. So I receive a body here from, I do a deep copy of the doc of the JSON. I remove this version from there because I don't want to consider this to generate a tag. Otherwise, it will always be different, as you may guess, because it will be version 1, version 2, version 3. Okay, then I just pre-compute a short hash of this JSON, this body here, and I'll take the first 8 characters. Okay, and then I'm using the weak approach, and you can see the version that I pop from the JSON, and I put the short hash. I'm saying for this version, this is the hash. Okay, if I add another version 2, it will be 2/. So it means that different clients can be editing different versions of the same data somehow, because I accept that. If it's not the case, probably you will not have the version, as I said previously, and you just accept one, but you have to handle, if your application can have multiple clients editing the same data, you should find ways to handle when it fails. Say, okay, I'm trying to update with something that was already updated. Maybe I'll return to the end user, say, okay, this is the new data. Like when you have a kind of a conflict in the GitHub, it's the same concept. You are trying to push to merge and say, okay, but someone changed the same rule. So what do you want to do? You should resolve the conflict. That's the same concept here. Okay, now I have the root, which will be the APIs. This is a get docs / the ID. In our case, will be always 1. And then if it's very simple to understand the code. So I'm doing a get. So I go to database and get doc ID. In case it will be 1, which means it is 1, and we'll get this content here. Or if it's not there, just abort with the usual code in HTTP. Create a tag, generate a tag, make a tag, which is with our algorithm here. Okay, so now I have the tag, and now I'm looking if there was a header that was sent on the get, call it if non-match. If it's not, okay, we just do this. We just JSONify, let's say, the items without the version, meaning that we'll return this title and this content here to the client. Okay, we put the tag that we calculated here about what we have, and we respond. So what the client will receive, the JSON, and an ETag that he can later provide on the next get or put. Okay, but if the get already brought the if non match, which means it should be handled like this, we can say, hey, if it's equal, it's the same tag that I calculated for the doc that I have locally and the one that you are sending or asking for it. I will just reply with the 304 without anybody, and again put the ETag on the response, because it's useful for a user to have a kind of a follow-up about the get, and just respond. You don't respond with the content because the content is already on the client. And now you have the other way, which is the put, but you can also use for delete, for instance, something like that. So in the put, it's the same concept, but you have to look into the other side. So first, let's see if the user sent an image header, meaning he provided me an ETag, and he said to me, only do the update, execute this put, if the tag is the same. If it's not, it means that someone else changed the code. So now I go to database and get the doc ID that it was supposed to be updated. Otherwise, I just respond with 404. So I couldn't find that ID. And now I will again create the tag with the row that I have on my database or the JSON. And if they are different, it means that the user is trying to update something that it's already changed between the time he get the information, he did the get, and now he has to put in this interval, someone changed the data. If that someone changed the data, I will say to them, I will not update the data because the precondition failed. What is the precondition? It's the ETag should be the same, and it's not, meaning that the ETag that you sent on if match, it's not the same as the one I calculated locally on my server. If it's not the case, it means that it can update. So I get the payload of the request, and you just update. If I'm using versioning, don't forget to increase the version. So we have 2 rows for that. We should create now a new tag for this, and we reply to the user. We expect this tag to be different, because if it's an update of the user, the previous tag will be removed, the tag, and now you have a new one, and you should reply with this new one to the client. Now maybe he wants to do another update with this date or do any. Remember that the client can be a kind of a table where you can edit, remove, insert new stuff, things like that. So you want on the client side to always have the ETag. So always reply with ETag, even if it's success on the get or on the put or delete. Always reply with a new one if there is new data involved. Okay, and the server, it is as is. The only thing that it's missing is create app and run, choose the part, and that's it. So these are, if you want to install Python, you can use this line just to create an environment. It's a good practice in Python. Just activate it. Don't forget to do a pip install Flask if you don't have installed on your machine, and execute your file. Now I will show you in a different way, but if you want the curl, this curl should work. Like this is a regular get, so you should see on the reply something like this. Okay, the hash and the content. If you do a get and there was no change, you will receive something like this. You will see this working in a few seconds. This is just to do a safe update. This is just to make sure that everything is sent to the server and you can read the output after you try to do the update. But at the end of the day, this is what matters in our service. Is this if match. You pass the ETag that was extracted before, okay, and it was updated, or on the reply you should see something like this, okay, because the update was successful. If the update was not successful, you should send something like if match, and you pass an old hash because there is already a new one on the server, and you should receive something like this. These are the scenarios. So checklist, if you want some guidance on this. So always return ETag on cacheable resource. Support if non-match when unchanged. Support if match, meaning put this on your APIs always. There is no impact or big impact on performance, and this way you make sure that you have a kind of a defense approach to your development. So generate via version, hash, or composite week, and of course store ETag version in database or compute on read. It depends on the algorithm that you choose. So let's see now this working. So this is the server. You can find the code on the GitHub, as I said previously, but it's here. It's quite simple. It's the same code that I have on the slides. If you pause them and you are the person that likes to write just to learn and to create a kind of memory about it, so you can use later, or you can just look into this code. This is the old code. You can just pause this video, for instance, and copy. I will scroll until down, and that's it. That's only this file. So now let's run our server. Okay, this is a development server. Of course, we are using Flask locally. This is not an error. It's just saying, okay, this is not good for production. We already know that. And now I have here the requests. So this is the host, localhost, as you can see here. And now let's get document with ID 1, as we saw previously. So it will send request, and you can see, okay, you can see that the version is not here. But if you go here, you can see it here. So it's not a good approach, and you should send the version because it doesn't participate on the execution. Okay, so but you can see here the ETag. Okay, that's what you want. It's a week version 1, and this is the hash that was computed. Okay, now imagine that we take this value here and you put it here. You can see it's the same I executed before, of course, before this video to make sure it works. But since it is an hash and I didn't change the code, so it always computes the same. So now when I send this request, you can see it was not modified because we didn't change nothing on the server about the data. We just did a get, and now we did another get. But I sent this if non-match, okay, meaning that give me the content, but only if this ETag it's not the same. That's what it means if non-match. Now let's do something. Let's simulate an update. So I'm updating with this content. It's a completely different one, and you can see here. If I request this again, it's content ETag demo hello. This one is document 1. This is the updated content for 1. But I'm sending on this update this one here. Let's see if it works, meaning that I got this data, I update to this one, and now I'll send a request and it'll say, okay, good enough. The version that I had here was this one, and you want to update. So I will update, and I'll give you now a new tag. You can see that this tag, it's different from this one because this tag is related with this content that represents the data that now exists on the database. But now imagine that I will try to update again with the previous one, which should be a problem because now the computed tag will be this one and not the previous one. So what will happen? We'll receive a 412, say precondition fail. You are trying to update with something, even if it's the same data, it doesn't matter. Here, but the tag that you are sending here, the ETag, it's not the one that I provided you previously. So you can defend your API against inconsistencies on the database. So it's quite simple, this kind of subject of ETags, but I think it's important for you to understand it because, as I said at the beginning of the video, usually people develop the APIs, but they don't think too much about these gets and these simple things that can create a kind of a safe barrier on the API against inconsistencies on the system. So I hope this was useful for you. Again, you can check this code from my GitHub. I hope you like this video. Please subscribe, share with your friends. It always gives me motivation to continue to do these videos completely for free. So thank you for watching, and I hope to see you on my next video.